Good afternoon, everyone. Am I audible? Am I audible, students? Can you hear me? Hello. Am I audible, students? Please respond. Write in the chat box if I am audible. Yes or no? Okay. Thanks, Janalvis. How many students have joined? 15. Acha, somebody please quickly tell me what did we cover up last class? If you have written the topic names that we discussed last class, can you tell me what did we discuss? You can write in the chat box if you don't want to speak, that's okay. Please quickly tell me, anyone, what did we do last class? Which topic? What happened? Nobody remembered or what? You don't write the topics in your copy while we discuss? Okay, so no one is responding, so I will assume that I have done up to chlorination part. Okay, I also forgot, but no one is responding. So I hope I have done your disinfection part. I have done up to sedimentation tank. No, where are you, Rohit? We have completed sedimentation tank. Like, so it is beyond, I think, 1 week we have completed. Sedimentation tank is complete. About to start coagulation. Coagulation I have completed. I have completed, my dear. Coagulation I have given the notes also. I was just confused about disinfection or chlorination I was doing. I remember that much. You people don't remember also what is going in the class. Okay, no issues. I am going to start from chlorination. Okay. Okay. So types of chlorination. Uh, we need to quickly end it up. Okay. So types of chlorination you see here. So there are seven types of chlorinations are there. So your plain chlorination, pre-chlorination, post, double, breakpoint chlorination, superchlorination, and dechlorination. Okay. So what is plain chlorination is what? When only your chlorine treatment is given and no other treatments are given to the water, then it is known as your plain chlorination. Okay, and this technique it is used in when the water it is relatively it is clearer. Okay, it has turbidity less than your 20 to 30 milligram per liter. Okay, also when this type of chlorination is used, you see, when water is needed to be supplied or distributed to army troops. Okay, during war times, when water needs to be supplied to army troops, so there is no time. Okay, there is no time for doing all the treatments. So in that case, what is done? Your plain chlorination is done. Okay, other treatments it is not given to the water, only your plain chlorination, that is only your chlorine is added to the water. Okay, so next is your pre-chlorination. Pre-chlorination is what you see when your chlorine it is added before your filtration process. Okay, when your chlorine is added before filtration process, or rather you can say it is applied before your sedimentation coagulation process, then your the process it is known as your pre-chlorination. From the name itself, it is pre. Okay, that means it is applied before. So and also it this pre-chlorination it helps in removing what coagulation, and also it reduces the loads on the filters. Okay, and what is the dose? The doses are 5 to 10 milligram per liter. Okay, so in this PDF the the important lines are already been marked up with pen, so you can write it down in your copy later. Okay, what is, and whenever your pre-treatment is given, pre-chlorination is done, it is always followed by your post-chlorination. Okay, so what is post-chlorination? It is after all the treatment processes are done. Okay, when all the treatments are done, at the last your chlorine, when chlorine is added to the water, it is known as your post-chlorination. So whenever pre-chlorination is given, sometimes suppose before your filtration or before your sedimentation coagulation process, at that in that case your post-chlorination is always followed by. Okay, so post-chlorination is chlorine is added at the end also. Okay, and what is the dose of for your chlorine for post-chlorination? It is 0.1 to 0.2 milligram per liter. Okay, so next is your double chlorination. So double chlorination is what it is, when pre-chlorination and post-chlorination is done together. Okay, or when the water it is said to be chlorinated twice, so that is known as your double chlorination. Okay, so here your pre-chlorination and post-chlorination it is done together, and it is known as your double chlorination. And this method it has the advantage same as that of your pre-chlorination. Okay, so this is about your double chlorination. Then you see for next is your breakpoint chlorination. So breakpoint chlorination is what it gives you an idea of how much chlorine it is being added to the water. Okay, it gives you an idea up to what extent your chlorine is added to the water, and also it whatever amount of whatever dose of chlorine is added, so that chlorine it will appear as your residual chlorine also. Okay, so it is written here, you see, it is written here from here. Breakpoint chlorination is a term which gives us an idea of the extent of chlorine added to water. In fact, it represents that much dose of chlorination beyond which any further addition of chlorine will equally appear as free residual chlorine. That means if you are keep on adding chlorine, so that further if you add chlorine, then it is known as your free residual chlorine. Okay, so there is one graph you see here. So this is one graph. So what this graph tells you that when you first add chlorine to the water, so this A to B, you can see this point A, wait, this point A to B. Okay, so what this curve suggests is that when you are adding chlorine slowly to the water, okay, and when the residual it is tested, okay, when the residual chlorine is tested, then you will found that the residual chlorine it will go on increasing, okay, with the addition of chlorine. Okay, so up to A and this up to A and B. So what this curve says you that when you keep on adding your chlorine and when the residual chlorine is tested, it is found that the residual chlorine it goes on increasing with the addition of your chlorine. Okay, so now from B to C you can see the curve has fall down. Okay, so why this curve has fall down is that when you are adding chlorine, okay, some amount of chlorine it is obviously used for, you are adding chlorine because you want to kill the bacteria present in the water. Yes, so when you keep on going the adding the chlorine to the water, so some amount of chlorine it is obviously consumed by the bacteria, isn't it? It is consumed by the bacteria, and after that only the bacteria are killed. Okay, so since some amount of chlorine it is consumed by the bacteria, so that some a residual chlorine it will slightly be less. Okay, it will become less than what you have added before. Okay, so B and C is that curve which shows that the when you are going on adding chlorine, some amount of chlorine it is consumed by the bacteria, and that amount of residual chlorine it is slightly less than what amount of chlorine you have already added before. Okay, so B and C shows that one. So again from C you can see that it increases. Okay, again from C the curve increases. So what that curve suggests is that, so when you chlorine it is continued to be applied beyond the point B, okay, so the organic matter present in the water it starts getting oxidized. Okay, so when you continue you add going on adding your chlorine beyond the point B, so the organic matter that is present in the water it gets oxidized, it starts getting oxidized, and what happens, the residual chlorine it suddenly falls down. Yes, we have already discussed. So now the from the point B, from this point C, this C point is known as your breakpoint chlorination. Okay, this C is known as your breakpoint chlorination. Okay, then after this, after some chlorine is consumed by the bacteria, therefore this curve has fall down, and this again from this point you can see that the addition of chlorine it again increases. Okay, so this point C point is known as your breakpoint chlorination. Okay, so the point C it is beyond which if you add any further chlorine it will appear equally as your free chlorine. That means beyond point C this curve has increased, so this means that any addition of chlorine, any further addition of chlorine it will appear equally as what, as a free chlorine. Okay, and C is known as your breakpoint chlorination. Next is your superchlorination. Okay, So superchlorination, it what it indicates is that it is super. From the name itself, you can imagine that it is the addition of excessive amount of chlorine to the water. Okay, it is the excessive use of chlorine to the water. And what is the dose of chlorine? It is 5 to 15 milligram per liter. Okay, and obviously it is this type of chlorination process is required in some, only in some special cases, like, when the river is highly polluted, or when, there is waterborne diseases are there, okay, in the water. So in that case only you use superchlorination. Otherwise superchlorination is not used much. Okay, so next is your dechlorination. Okay, so after you have done excessive amount of chlorination you have used in the water, so obviously you need to remove that chlorine. Okay, after the bacteria are, they got killed and all. So after that, because if that chlorine it will remain in water, then obviously it will give you bad taste when you drink it, isn't it? And chlorinated water no one can drink. So what is done, you have to remove the chlorine from the water, and that process of removing the chlorine from the water is known as what? Is known as your dechlorination. Okay, so dechlorination, it is simple, just removal of chlorine from the water is known as dechlorination. And what are the common dechlorinating agents you see? It's written here. The common dechlorinating agents are your sulfur dioxide, sodium thiosulfate, activated carbon, sodium metabisulfate, sodium sulfide, sodium bisulfide, and ammonia. Okay, these are your common dechlorinating agents. Okay, so this is all about your chlorination. Okay, types of chlorination we have studied. Clear? So next is your, after you have done disinfection, now comes your water softening process. Okay, so you have killed the bacteria. Okay, you have killed the bacteria by you have added chlorine, and you have killed the bacteria. But now, what to do about the water, to those water which are hard? Okay, because we have already studied about your temporary hardness and permanent hardness of water. Okay, so we need to remove the temporary hardness of water, and also as well as your permanent hardness from the water. Okay, so what is water softening? The definition will be the reduction of removal of hardness from water is known as water softening. Okay, it's very simple. It is written here. The first line you see, the first line you see, the reduction of or removal of hardness from the water is known as what? Water softening. Okay, so let's see how to or what are the processes. Okay, what are the processes to remove your temporary hardness? We already know that hardness are of two types. One is your temporary hardness, and the other one is your permanent hardness. Okay, so what is temporary, how to remove the temporary hardness? Temporary hardness, it can be removed easily. Okay, it's not that tough to remove, or it doesn't needs a very hard process. So number one is your boiling. Okay, so when you boil the water, okay, when you boil the water, what happens? The calcium carbonate, okay, the calcium carbonate, or you can say the calcium bicarbonate, that is present in the water. Okay, because we are studying about hardness, and we know that hardness is what? Carbonates and bicarbonates of calcium and magnesium. Okay, so when the calcium bicarbonate it is present in the water, and it is dissolving in natural water, okay, containing a carbon dioxide. So when such a kind of water it is boiled, the carbon dioxide gas it will get evolved. Okay, it will get evolved, and it gives a precipitation of what? Calcium carbonate. Okay, it gives a precipitate of calcium carbonate, and carbon dioxide gas is evolved out. Okay, so these things, it doesn't need much explanation, I guess. Okay, because this is you have to remember the chemical equation. Okay, so this is, you see here, calcium bicarbonate equation is given here. So when you heat it, so what precipitates, calcium carbonate is precipitate, and your carbon dioxide gas is evolved out along with the water. Okay, so methods of removing temporary hardness are: number one is boiling, and the other one is your addition of lime. Okay, so you need to remember uh, addition of lime. So addition of lime also, there are three equations here. Okay, so what are the precipitate? Magnesium hydroxide, calcium carbonate, all these are precipitates. Okay, you can see this symbol. Okay, this symbol wherever it is, that means it is precipitate. Okay, so by addition of lime and by boiling the water, you can remove the temporary hardness from the water. Okay, so you write down, okay, in your copy all these things. So next is your how to what are the methods for removing, permanent hardness. Okay, so permanent hardness also you see here. Just you need to remember the names and little bit of the definitions. Okay, not to go much through. Number one is your lime soda process. Okay, lime soda process. Number two is your base exchange process. Okay, which is also known as your geolite process. Okay, and number three is your demineralization process. Okay, so here also lime soda process also here, from the name itself. Okay, when your lime and soda ash, these are added in the water. Okay, it reacts with the calcium and magnesium salts. Okay, and it gives a precipitate of calcium carbonate and magnesium hydroxide. Okay, so this is also your basically involves all the chemical equations you see. Okay, so this is also you have to write these chemical equations. If you can remember the chemical equations, then you can write the little bit 2-3 lines from yourself only. Okay, just explain the chemical equations. Okay, so lime soda process is given here, all these equations you see. Okay, so when you add lime and soda to the water, so that removes your permanent hardness. Okay, so like this is a recarbonation plant. Okay, where your this so lime soda process is done. Okay, then your, actually these are very lengthy, but no need to go through much about this. You can, if you take later elective subject as your environment, then you can study all these things. Okay, so like geolite exchange process or base exchange process, these also, geolites are what? Geolites are your natural salts or clays. Okay, these are natural salts or clays, and which are hydrated silicates of sodium and aluminium. Okay, and this has a chemical formula. The geolites, it has a chemical formula, this one. Okay, so here what is done actually, what these geolites, okay, the geolites or the resins, it is also known as resins also, and resins are, these are manufactured synthetically. Okay, so resins, it has a excellent property of what? Exchanging their cations. Okay, cations, anions, everyone knows, I guess. Okay, in chemistry you have studied about all this. So these have an excellent property of exchanging their cations, and during the softening process, obviously during the softening process, and the sodium ions of the zeolites, it gets replaced by the calcium and magnesium ions present in hard water. Okay, so this is the work of your zeolites. If somebody asks you what does a zeolite do, then you can say this line. Okay, the zeolite, it has a excellent property of exchanging the cations, and the sodium ions of the zeolite, it gets replaced with the calcium and magnesium ions present in water. Okay, so like this, with this processes, you can remove the permanent hardness. Okay, you can remove the permanent hardness of water, and also there is a difference between uh, lime soda process and zeolite process of softening water supplies. So you can go through 1 to 5 points. Okay, 5 points, five, you take five easy differences. Okay, so you can see 1 2 3, and here are 12 differences. Okay, so 12 differences are there based on the different items. So you pick out some easy differences according to you. Okay, five differences you write down in your copy. Okay, remember to write down five differences between your lime soda process and zeolite process according to the items. Okay, any five you write down. Okay, then after your softening process, with the softening process, actually your normal treatment process it is finished. Okay, so softening was the last treatment process, but actually what happens after softening also, there are some kind of minerals. Okay, there are some kind of minerals, like you can say iron and manganese, you can say iron and manganese, and also there are certain taste, the odor, color, all these things. Okay, still there are some taste, odor, color, or some minerals. Okay, those are present in the water also. Some dissolved gases, like you can say hydrogen sulfide gas, then carbon dioxide gas, all these things are present, still it may be present in the water. Okay, so for those reasons we need to give it some special treatment. Okay, after giving those normal treatment process also, we need to give some special treatment processes. Okay, so these special, what are the special treatment processes are, you know number one is your how to remove the color, odor, and taste from the water. Okay, your color, odor, and taste. Okay, so number one is your aeration. Okay, so what is aeration process? Aeration is what, it is a process which is given when oxygen is given to the water. Okay, what you see here, it is written here, under the process of aeration, water is brought in intimate contact with air so as to absorb oxygen and to remove carbon dioxide gas. Okay, so the ultimate work of the aeration process is that uh, water it is given, okay, air. Okay, air is water it is brought in close contact with air so that the water it absorbs oxygen, and carbon dioxide gas it is removed. Okay, and also it helps in killing bacteria also to a certain extent. Clear? And also it, what it is written, it also helps in removing hydrogen sulfide gas and iron and manganese to a certain extent from the treated water. Okay, and aeration is done by some different processes. Okay, so let us see now the two of the processes. Let us see. Number one is your by using spray nozzles. So in this method, there are certain nozzles. Okay, there are special nozzles are there. So which is faced to the atmosphere or to the air. Okay, and water is sprinkled in the air. Okay, where water is sprinkled in the air through using these special nozzles. Okay, and where the water it converts into droplets. And after when the water it is converted to droplets, it no the dissolved gases like carbon dioxide it is removed from the water. Okay, so also in this process a certain head of water it should be maintained, and a certain head of water it should be maintained, and the head is what, 10 to 14 meter head of water is used for this process. Okay, and how much of carbon dioxide gas is removed? You can say up to 90% of carbon dioxide gas is removed by using this spray nozzle process. Okay, and number two is your, by permitting water to trickle over cascades. Okay, so water, this what is this process? First I will show you one diagram. So this is a original photo, okay, of a cascade aerator, and this is a, sectionic view of your cascade aerator. Okay, this thing you can see there are steps. Okay, some steps are provided, and what is done through this pipe, the water, the water, it goes, okay, to this, and water is, it is flowing through the steps. Okay, so what is that name? It is known as your cascade aerator. Okay, so you see here in this method, the water is made to fall through a certain height, and what is the height is 1 to 3 meter. Okay, over a series of steps, as I showed you. So series of steps are there, and the water is allowed to fall through that steps. Okay, and what is the height of each step? It is 0.1 to 0.3 meter. Okay, so the structure it is so formed is known as a free fall aerator, and the simplest type of the free fall aerator is also known as what? It is known as your cascade aerator. Okay, so this is our, and this process, it also, when the water it falls through the steps. Okay, so what happens, the carbon dioxide gas, it is being removed and oxygen is being supplied to the water. Okay, so these two steps, if you remember, this then it's fine. Okay, aeration is a process. Okay, so next, I don't have the photo with me right now. Okay, so let me tell you another one. Okay, so this is your aeration process. Okay, this was your aeration process. I don't have it with me right now. Okay, but I'm explaining it to you. Later I can provide you the PDF. Okay, so next one is your another process is what is to offer removal of color, odor and taste. Okay, odor and taste, how to remove? By, treatment with activated carbon. Okay, so activated carbon, it is what? It is a specially treated carbon. Okay, and it has the activated carbon, it has a property of what? Absorbing and attracting the impurities. Okay, you know, the it has activated carbon, it has a property of absorbing and attracting impurities. Impurities, you can say, such as gases, liquids, and finely divided solids. Okay, so because of its, excellent property of absorbing the impurities, it is widely used for removing what? Taste and odor from the public supplies. Okay, so and how, what is activated carbon? It is manufactured. Activated carbon is what? It is manufactured by heating wood. Okay, wood or sawdust. You can sawdust also, everyone knows sawdust, or you can say some other, similar carbonaceous where carbon is present. Okay, by burning those carbon type of things, at 500 degrees Celsius, your activated carbon is, manufactured. Okay, so by activated carbon also, your taste and odor, it is being removed. Okay, so with this, we have come to the end of our treatment process. Okay, so treatment process we have almost finished. So in your first module, uh, we have your, one more distribution system we need to cover up. Okay, so we need to cover up the distribution system. Let me see if I have the notes with me. Just wait. Okay. This one I have with me some uh, distribution system. Okay. So I will give you the PDF later. Okay, in the next class or by today, I can provide you the PDF. So your treatment process is finished. Okay. So after you have done the treatment, okay, to the water, okay, after the water it has been properly treated and made safe, okay, so that it can be supplied to the consumers in their individual homes, okay. Now the water, it has to be taken from the treatment plant. Obviously it has to be taken from the treatment plant to the roads and streets in the city, and then it finally to the what individual houses, okay. So this function of carrying the water from the treatment plant to the individual homes, okay, is it is accomplished through a well planned what distribution system. Clear? So it is a distribution system, it what it consists of, pipelines of different sizes, okay, for carrying the water to the streets, okay. Then it contains valves for controlling the flow in the pipes, okay. Then again there are hydrants for providing connections with the water mains, okay, for releasing water during the fires. So all these things, then meters are there for measuring discharges, okay. Then service connections are also there, so to the individual home, service connections are there. Then pumps are there for lifting and forcing the water to the distribution mains or distribution pipes, okay. So all these things, it is combinedly known as your distribution system. Okay, so distribution system, there are certain requirements of a good distribution system. Okay, there are certain requirements. So number one, you can say that it should be capable of supplying water at all intended places within the city. Okay, so it should be able to supply water at all the places within the city, okay. And also it should be capable of supplying the proper amount of water for fire during the, if fire breaks out, then also it should be able to supply a proper amount of water, okay. Then also it should be cheap and with the construction cost, it should be less, okay. And it should be simple and easy to operate and repair, okay. It should be simple and easy to operate and repair. And also this one, it should be safe against any future pollution of water, okay. So all these things are your good requirements of a good distribution system. There are certain points, I will provide you the PDF, okay. So again, and there are some layouts also for the distribution system, how the pipes should be layout, okay. So all these things we will cover up in your Friday class. So okay, these are, you can see, these are the layouts. We will discuss it in the Friday class, and we will complete this module 1, okay. Module 1 we will finish, and we will quickly, we need to go to the module 2, okay. Okay, so with this, let us end today's class. Let me take the attendance. Okay, roll number 1.
Yes, ma'am.
Okay, 2,
Yes, ma'am.
3,
Present, ma'am.
4,
Present, ma'am.
7, roll number 7.
Yes, ma'am.
Okay, 8, 9, 10, 11,
Ma'am.
11 present. Okay.
Yes, ma'am.
12,
Present, ma'am.
13,
Yes, ma'am.
14,
Present, ma'am.
15, 16, 17,
Present, ma'am. 17 present.
17, 18,
This is my report.
18 is present.
Yes, ma'am. 18
Okay.
is present.
19,
Yes, ma'am.
20,
Present, ma'am.
21, 21 present. 22,
Yes, ma'am. 22.
okay. 23, 24,
Yes,
25,
ma'am. Ma'am, 24.
Within, ma'am.
okay. Okay. 24, 25 present. 26,
Present, ma'am.
okay. 28,
Yes, ma'am. Yes, ma'am.
okay. 29, 29, 30,
Present, ma'am.
okay. 31, 32, 32, 33, 34, 35, 36, 37, 38, 39, 40,
Yes, ma'am.
okay. 41,
Present, ma'am.
okay. 42, 43,
Yes, ma'am.
43 present, okay. 44, 45, 44
Ma'am,
present, okay. 45,
45, 40.
okay.
Present.
Okay. 46,
Yes, ma'am.
47, 48, 49, 50. Who else is left out? Please write in the quickly in the chat box. I am telling the absent ones, okay? Just see. 5, 6, 7, 8, 9. Okay, 9, I think he has given attendance in the chat box.
Present, ma'am. 9.
9 is present, okay? Okay. 9.
Ma'am.
Okay, then 5.